Hey everyone, I'm going to be trying out live commentary today, which means I'll be, I guess, explaining my thought process as the contest goes on. Not really sure how well that's going to go, but I mean, should be fine. I'll also explain my solutions at the end and I guess put that timestamp in the description. Yeah, that's working, right? Good. So we wait for it to begin. Just going to open all the problems. Okay. So E has a subtask, which is interesting. Game starts in a square flat grid. Line borders built up. Light blue and yellow blocks. Just touch the built. I guess the built block here on the previous turn's figure by a side. Any number of blocks. What? Is this one of those fancy n/2 problems? Okay, so for 2 by 2, it'll take 2. For 4 by 4, you can put the blue ones down. Wait. Okay, you can put the blue ones down here on the sides, and the yellow ones there, and the blue ones there. It's not very clear, but it means you can do it in 3 turns. And then 5. Doing 5 will also take, let's see. Five, you can kind of build these 9, and then here you can put those down. No, that would take too long. What if we did this instead? Then we would put these down here. So my guess is because it's uncomment that. So the pattern is 1 takes 1, 2 takes 2, 3 takes 2, 4 takes 3, 5 takes, let's see. So you can put all of these down. So 5 will take 4. Because why does 5 take 4? You put these down, and then these down, and then these down, and then that one. Or you can put them here, but that will take longer. So let's not do that. Okay, for 6, it will take, put these down. Then these down. This is not easy to visualize. How many does it take for 6? Alright, let's pull up the... So we have... I'm not sure what to do here. We have this, that, that, that. I'll make the grid more clear. That, and that. And then we have this, that. This is kind of a 6x6 grid in a way. 2. And then here we have that again, 3. Then we're left with a 2x2. No, wait. Okay, so this is also 4. And I missed this one before. So how does this work? You'll want to... Oh, there should be some simple, like, pattern here, I guess. So 5 takes... How many does 5 take? Take 1, 2, 3, 4. And then 6 will take, because you can put these down and they're symmetrical. Then you'll put all of these down. Okay, so if it's odd, alright. So if it's odd, let's just try more things. This is taking a concerningly long time, but it's just A, so it doesn't really matter. So if it's odd, you'll put these down first, then these down, then these down. Okay, that's quoting this statement. These down, these down. Wait. So odd, it's optimal to do it this way, right? So it's 1, then that, then that, then that, then that, then that. Okay, so if n is odd, it might be some like one-line pattern, but whatever. So if n is odd, you can always place a pattern that goes like this, like 1, 2, 3, 4, 5, 6. So that will take m minus 1, and you'll eventually reach the center that way. Wait, 1, 2. Oh, but you'll place these down too. Wait, so if it's 5, you'll put these blue ones down, and then these yellow ones down, and then these blue ones, and then that. If it's 7, you'll put these blue ones down, and then these yellow ones down, and then these blue ones down. Wait, so that takes 4 too? Blue, yellow, blue, yellow. And this is blue, yellow, blue. Wait, you'll get, if you put these down, you'll get all of these. Okay. It's not necessarily an easy A, I guess. Don't know what's going on. Blue, yellow, blue, blue, yellow, blue, yellow. Guess it'd be that. And with 5, it's yellow, blue, yellow. Oh wait, okay, so 5 is only 3. So I guess the pattern is this: 6, 4, 7, 4. So it'll be n plus 2 over 2. Comment that now. It's n plus 2, right? Yeah, floor division. Okay. Alright, I guess we'll see if that works. Don't really know at this point. Alright, I guess we should definitely try to be faster than that, especially with A, but whatever. Okay. Oh, that was kind of like working out the samples wrong, so that's mostly my fault. Still has its M planks. See the plank with length X. One plank with length X was removed. Rectangular and square storages. So okay, so the number of this is much easier. So for this, both the number of and plank equals 0. So for this, the number of planks must be divisible by 4, right? Unless they... Wait, is it 2 storages? Oh, it's just 2 storages. Okay. Alright, so what we'll do is we'll... Alright. So there's no test cases, which means we can... Okay, so you have to build exactly 2 storages. So there has to be one type of length of plank with at least 4 occurrences, and then either another type of plank with 4 occurrences, or 2 of them with 2 occurrences. So we'll see. Okay, so we use B as a count of the length of each plank, and then C as a count of each length of occurrences. No, that doesn't work. Alright, we'll store a multi-set of occurrences, I guess. So for IN plus BI for IN if BI mod 2 is equal to 0. Okay, now then awk.arrays. Wait, if bx mod 2 is equal to 0, then bx plus equals change. If bx mod 2 is equal to 0, insert bx. So if there are at least 3 different lengths with even lengths, then automatically that's satisfied. Otherwise, let's say there are no elements at all. Then if there's exactly 1, then there has to be at least 8 because you have to form 2 squares from it. Otherwise, it's not possible. Otherwise, this is exactly size 2. So let's see. If A is at least 4 and... Wait, no, what am I doing? Because it doesn't have to be necessarily even. Okay, this is a bit messed up. Because it doesn't necessarily have to be even. Yeah, okay, wait. Let's get rid of this then. Yeah, what we'll do instead is we'll update this. And we'll just check, see if it's possible. So knock.size, return false. If it's less than 4, then we can't make a square, so return false. So for all x awk, then if x equals 1, we can't use this, so break. If count is greater than or equal to 8, break. What now? Okay, why do I keep clarifying things? These are in the statement. What? I have to read in the number of queries. Epic, why is that true? So the reason I check if it's greater than or equal to 8 is because first you need 4 to make a square, and then... Oh wait, okay, what am I doing? If x mod 2 is equal to 1 minus x, so we take an even amount and then count plus equals x. Then we move that here. Yeah, because we have to take an even number of planks. Okay. Why is that happening? Oh wait, because it's sorted in that order. Yeah, that makes sense. So I have to take the biggest element and check if that's greater than 4. And it's still not working. Nice. Why? Okay, so it's not even getting there. What? Why is it not getting there? Okay, let's try that. Should actually see what's going on. Oh. Well, that makes sense. Yeah, we should actually use the array elements. Okay, that should work now, because now we're actually using the input. No, yes, no, 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 yes. Okay, and that is because in here we have 2, 5. That looks right. And here we have 2, 5, then we have 2, 6. Then we have 2, 5 again. Then we have 3, 5, 3, 4, 4, 4. Okay. Let's get rid of the debug printing, test it again, just to make sure. We'll admit this is not the best time for solving A and B, but I mean, whatever. It's div 2, doesn't really count. Just copy the input. Nice. Alright, what's with that? Initially, the company stars as n planks. Okay, let's check this first. So there are node multitests. Read an n, read an array. Set the counts to 0. Counts are bigger than 10 to the 5th. Counts are bigger than 10 to the 5th. Counts are at most 10 to the 5th, so we'll insert the ones with greater than 0. Then read the number of queries. Read in each query. Set its change appropriately. Remove exactly one instance of that because that's how multisets work. Change it, put it back, and then check if it's possible. How do we check if it's possible? Just sanity check. How do we check if it's possible? Well, oh wait. Ugh. Okay, this is a problem. Alright, so what I'm going to do is I'm going to just insert things by negative numbers. And then it's greater than -4. X equals -x. That way they'll be ordered in decreasing order. Yeah, so the biggest one will be first, and then that way we can have this condition. That's annoying. Didn't realize that would be an issue. Okay, why? That works, right? Because we immediately get rid of the negative thing so it doesn't really break anything. And we do it everywhere. Okay, let's try again. Alright. I'm not even going to check my place right now. I'll solve more problems first. Considering that we have a wrong answer on B and 600 people have solved it, it's probably not that great. Okay. One by one. Likes having fun. The same, what? Try not to eat, but the same filling way too often. So the minimum distance. Okay, so only the same, nothing about being near each other. Oh boy, okay, so we read multitests again, and we still read an integer n and an array of length n, so we can keep that. Then it's any order, so I'm guessing we have another count array. It's great. Then okay, so we can have the minimum distance be x if, let's see, how would this work? So we don't have to reconstruct the sequence, which is nice. Okay, everything with one occurrence is free. Everything with, yeah, we can do whatever we want with those. So for example, the 7 here, we can just have that in the middle to increase the distance. Which means I guess we're, 1, 1, 4, 6, 4, 6, 4, 7. So that 7 is useless. We'll put the 4s apart and then fill in the rest with whatever we want. So I think it's true that we only really care about the elements with the largest number of occurrences because we can kind of like interleave the other elements in between them. Yeah, here, let me try and illustrate this. This is what I'm thinking. So we can, let's say we have like 1, 2, alright, let's say we have like 3 is the one with the most occurrences, so we're going to try and put some stuff in between it. Let's say we have a 1 with 2 occurrences, we can put them here. And let's say 1 also had 3 occurrences, we can put it on this side. So now we have essentially 3 separate gaps where we can put whatever numbers we want. And if a number has 2 occurrences, we'll put one here and the other one here, and it'll be no worse than this. So essentially, we're only going to care about the ones with the most number of occurrences. And we also want to make sure we put the most number of numbers in between. So my guess is we count the number of ones with the greatest number of, or we count the number of elements that belong to a number, that have a number, that have them. That doesn't make sense. I'm just going to write it. And then I'll explain it, I guess, more articulately after. So map int counts. So just call it count because that's easier. Then it's log in, so it doesn't really matter that I access the map again. Who cares about constants? Yeah. Alright, so now elements are up to n, so I'll just make it a bit easier. Wait. Oh wait, okay. So essentially, even though we have multiple elements with occurrences 3 here, we can still wait, okay. So the strategy is to first put all the elements with occurrences 3 down, and then we're going to fill in these 2 gaps with whatever we can. And so first we count the number of elements, max C. We count the number of elements that have the max number of occurrences. If count I equals max plus max C, then rest equals n minus max C times max. These are the number of elements we have to fill in. Now we have max minus 1 gaps to fill in. So essentially we have, so here we'll have 2 gaps, and that means we're going to put in as many elements as we can, and it's essentially the floor of, I'll use a different color. It's the floor of, let's say, x is the number of elements we have divided by the number of gaps we have to fill in. So it's rest over max minus 1, then we get C out. We also get an additional unit of distance for every other thing that has the max count. So max C minus 1 plus fill. That should work. If it doesn't, I don't know what I'll do. Okay, cool. That's because I should reset that. I could just do count.clear. It's easier. Doesn't really matter. In fact, I don't even need a map because I can just use a big array, but alright. Let's submit. "9-minute A and an 8-minute C. Nice. Okay. Should be doing slightly better. Let's check my friends. Alright, 1/38. I mean, it's not the greatest in terms of speed, but I can do better. Whoa. Whoa, whoa, whoa. That's gonna be cool if he becomes a master. Okay, let's get back to it. So, I think this is enough explanation in the... Yeah, this is basically the whole answer. So when I explain this later, I'll just link to this timestamp where I do this. Where did my mouse go? Okay. Carousel Boutique is busy again. Actually, how's my room? I'm in one of these Div 1 rooms where everyone's a tryhard. Yeah, okay. That is not great. Carousel Boutique is busy again. Ponyville needs a new dress. Of course, that's a string problem. Alright. Piece multicolor fabric, n times n square scrubs. Oh boy, a rhombus. What? Seriously? First one consists... Oh, how many ways? Wait. Okay, still. So how many rhombi exist? I do not like this at all. Wait, why are there 12 then? Oh, okay. Okay, let's see. So initially, alright. String mat 2004. No, just 2005. For IN. Power of macros, I guess. Let's see, has anyone solved E1 or is D the one to go for? Okay, we're going for D. Because E1 is almost worth the same amount of points as D, which is scary. Alright, how do we do this? So I guess first we'll fix the center of the rhombus, and then we'll, I don't know, do some weird binary search to see how far we can go out. I guess that would work. Let's say here, I'll take a screenshot and then show you what I have in mind. So I will, essentially what I can do is, what? I don't have a way to, seriously? I don't have a way to rotate it by an arbitrary angle? Alright, great. Anyway, the plan is to essentially like rotate it by 45 degrees. And you can see what that'll do is that will, instead of being a rhombus, it'll actually be a square. And that way we can use some like weird form of prefix sums to, I guess, then we're just counting the number of squares we have, which we can do in O of n squared with the dp. I'll explain more of that later. Rotate image 45 degrees. Oh my god, here, let's try something else. Maybe paint 3D is better. Copy. New. It's better work. What? Ah, this is terrible. This is terrible indeed. This is absolutely terrible. Stretch and skew. So what? And skew your image horizontally to the right of 45 degrees. What? That did not work. Alright, we're gonna try again. What if we did skew both angles? No, that's not what I wanted. Alright, you know what? I'm gonna explain this after because this is taking up way too much time. Essentially, the idea is rotate the grid by 45 degrees, and I should get a better drawing app than Paint, I guess. Or I'm just doing this wrong. Okay, there's gotta be like, if I do it like this and then like that, that's so screwed up. 45, negative 45. I mean, that's better. You can see how it kind of forms a square, right? Like if I, if I just, it's terrible. Alright, but the point is, we'll do that. Then the array is going to be twice as large. So what we need is car at 2. I'm just going to make it 4500. Then okay, I guess we can do coordinate compression on this. This is getting more and more complicated by the minute. Okay, so ms, oh wait, first we don't read in test cases. Mat 2, 0. Alright, okay, hang on. So 4i, we're gonna initially fill it with let's see, equal signs. Mat ij equals signs, so we can just see how this prints and then make sure we're doing this right. And then once we do that, we can do some square prefix sums, and it's going to be great. It's going to be great. Wait, 4,000, 2,000 squared times 26. How much memory is that? No, that's too much, isn't it? Is there a way to do this that isn't annoying? How many people saw this now? Okay, not that many more. Maybe there's a way to do this that doesn't require it being really annoying. Since the timeout's 1 second, so they... Oh wait, no, never mind. What was I thinking? I reformed my own approach. So, epic. Alright, so... squared times 4. Wait, that... Okay. So, int dp 4500, 4500. Then, so what we're gonna do is just for in, for jm, chords ij equals, this will in some way rotate it to be what we want. Then we're gonna do coordinate compression on x, and also y. I'm just gonna copy this and then make a compress y method or function. Okay, that's fine actually. Alright. Vector v for in, for jm. We're going to insert into v, push back ij dot first, sort v. Now for I dot size, if I is greater than 0 and vi. This is standard coordinate compression stuff again. Oh wait, VPO. No, it's not that simple. Vi dot f is not equal to vi, so on dot first. Plus we'll see. And chords ij dot, no, what? Chords vi dot, yeah, that's the stuff. Okay, now we're just going to change that, and that, and that. Should be m. Alright, should be mat2. Mat2 chords I dot f. Wait, chords ij dot f, chords j dot s equals mat ij. Then we're going to print this and make sure it works, because once this is fine, we're in the clear. for IC. Oh, okay, wait, we're gonna make this count of rows and count of columns, because otherwise it's gonna be too painful to do. CR, CC. CR, AO, mat2, I, CC. And this should print everything, unless the entire thing is broken. What? What? What is going on here? Oh, I missed the paren, I guess. Line 107. Indeed I did. Okay. Don't know why I always seem to make that mistake. Oh my god, it actually worked. Wow. That is awesome. Let's just make sure it works all the time. AB, AB, AB. Awesome. Okay, so that's what it's like to rotate a thing by 45 degrees. So now, as you can see, all of the rhombi are actually going to be squares in this. For example, this square was originally a rhombus. So now what we can do is we can essentially do a form of DP to count the largest square of, let's say, A's that this element is the bottom right of. Okay. Then once we do that, we just count like everything, and then it's perfect. And so notice also that these are 2 apart, so we have to not, like it's this type of square. It's like this A and this A and this A and all of these. And yeah, it's gonna be slightly annoying to handle that, but not that bad, I guess. So, okay, for what is it? MSDP0. So for ICR, for JCC, number of squares. I actually don't remember how to do this DP, but I know that's been done before. No. Number of squares. Just number. Why largest square? Number of squares. Dynamic programming. Let's try that. Why? What are you doing? Okay, well, it's something like, so it's part of a, like, what was it? It's something like max of, or no, minimum of, wait, okay. This is not cheating because I've solved this problem before. And I remember that there was some analysis of, what was it? It was on the range, and then, yeah, this is the exact same problem. So it's minimum of, yeah, to the left, wait, what? I'm guessing it's above. How does this work? Okay, so we, this is very intense on the memory, isn't it? No, it's not. What am I talking about? Okay, so first we're going to do it horizontally. So, actually, for ICR, for JCC, IJ, we'll just set it to infinity. Then we're gonna go horizontally. So by row, then what would it be? We need two separate counters actually. LO. No. Let's do this. Int j equals 0, j cc, j plus equals 2, car last equals a. No, just like hashtag. And then int, write that again, int run equals 0. Then if mat2 ij is equal to last plus run, else last equals mat2 ij, run equals 1. dpij equals min, dpij, run. Then we're going to do the same thing, but starting at 1. Then we're going to do the same thing, but for going down by columns instead of rows. Yeah, okay. So this is per row. I'm just going to switch all of these painfully and slowly. Why does it go up? It's annoying autofill. Okay, dp ji, 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 ji. And that should work, right? Because it's like that. I don't see why it wouldn't. Then, okay, now for ICR, I is greater than 1 and j is greater than 1. dpij equals min ICR AO dpi cc. So totally make sure that works, because I don't want to do anything dumb. Okay, so that should not be 2. Oh, wait. Okay, so it should be if mat2 ij is equal to mat2 I minus 2 j minus 2, because they have to be equal. Then that, otherwise you get something like this where the square is always blocked out. Ij equals 1, because you only get that square. Let's try again. So all of these should be that, except for, yes, these form a square. Awesome. Now, comment this out for now. If mat2 ij we add dpij because like each square that ends here is going to be a square of its own, and each square that doesn't end here is going to end somewhere else, so we can just sum over all that, and we get 20, because we're actually supposed to count not equal. 10, 14, what? Oh boy. What's with that? So this is 1, this is 1, this is 2. That's... Okay, that's slightly annoying because yeah, so the issue here is we have to check stuff in the middle. So if I run it on this one, it's going to get the right answer. But not on this one, so I'm glad this was a sample. Because what it means is, yeah, this square and this square shouldn't exist because, well, it doesn't work. So wow, this is not fun. There should be a better way to do this, but this is all I can think of right now. So there's a way to fix this. First we check if this square is also filled in. So, but then at the same time, these two conditions, the number of uneaten, or the number of same grid units to the left and the number of same grid units above, they also have to count these ones in between. So we have to look at these B's. How do we do that? The answer is not in a good way. Not in a good way indeed. Okay, so all we can do is first we impose this condition, ij at 2, I minus 1, j minus 1. Then we also have to fix these. And mat 2 ij is equal to last, and I equals 0, or let's see, mat 2 I minus 1, j minus 1 is equal to last. And I think that will work. I hope that will work. I think that looks right. And then we set the same thing here, except it's a different condition. And it has to be j minus 1, I minus 1. And we exclude I equals 0 because there's no column to the left of it, or no row above it. So let's see what we can do about this. Gives us 10. Alright, I'm definitely expecting wrong answer here. I'm going to create a few more samples just to make sure this works. Okay, so what we want is, we want a thing where it's, let's say 3, then we want to kind of screw up our own program, which is not exactly easy, but okay, so it has to be 5. Then what we want to do is we want to make it so these are all easy. Wait, how does this work? It should be A, B, A, then one. A, B, B, right? So then we don't really care about these, right? So they can form square, they can form, each of these will only contribute one because you can't have more than one rhombus, so the answer here should be 26. What? Right, 5, 5. I just saved it. 27, why? Where is it here? Okay, we should, it's, I guess, good that I caught that then. We'll take this out. What's with that? Don't like that space there. Print EP again. Oh wait, that doesn't work at all. It's not effective. So where are we getting things here? That's 3, fine. That's 1. That's 2, that's 1. Where else is it? 1, 1, 1, 1, 1, 2, what? Where's that? Oh boy. Oh wait, no, that is a rhombus. Okay. Good. So it still works. Good. Okay. That scared me for a bit, because I don't really want this whole approach to be wrong after all this. Okay, so this is in fact the correct answer, because we have another rhombus here. Let's make sure it stays correct when we orient it this way. And it does. Wait. Yeah, okay. That works, I guess. Submit it. Probably get wrong answer, figure out what's wrong with it, and then, I don't know, just go from there. Pretest 7. Oh my god. Come on. Come on. Give me a break. Give me a break. I don't know why we did that, actually. So we can make this short, and then pair short, short. That will work fine. It's not gonna compile. Alright. Of course you don't compile because you just wanna be happy with your types, don't you? You happy? No, you're still not happy. Why are you still not happy? I made you short. What? Alright. 10,000. Min short int int. What now? What do you want? Min short int int. Why is it on the parens? Min dpij. Okay, how about short 1 plus all that? Okay. just retest on all the samples just to be safe. Didn't copy that one. Okay. This should get rid of the MLE at least. Now we can get wrong answer successfully. Okay. We passed the big one. What does that mean? Why is it hanging on pretest 8? Time limit exceeded. Oh boy. What do you want? Okay, wait. Is this too much for memory? Should be fine. Alright. So V I times M plus J equals that. Then VV plus V plus max. Then for I max, do you compile? It's not compile. Great. Oh wait, okay. Vi.s divided by M. Vi.s mod M. And you still do not compile. Why not? Vi times M plus J. Oh wait, right. Cool. Then we replace that with this here as well. For IN, for JM, because everything else is n squared, so this, I guess, should be the bottleneck of what's happening. Let me set that and that. Unless it's just straight up too bad for n squared, but I don't know what to do about that. It's 0. Why is it 0? What? Man, this is such an annoying problem. I don't even want to know what E is. Honestly. Okay, why does that change anything? No, because clearly that... But what exactly did I do before? How did this work? Chords vi.s.f. Oh, right, wait, okay. That sets it there. And then the coordinates are working, right? So what's the problem? Why does that suddenly absolutely destroy everything I've ever loved? What? Like, it's not printing anything. Wait. Maybe CR and CC don't exist. would they know exist though? 5 and 0. Alright, so copy paste it. Okay, that's fine. Issues of... I don't even know. Let's get rid of this debug now. And there's no reason to stop working on the samples, but you know, can't hurt to be safe. Now I can still see this timing out, but no. Made it past pretest 8. So we're gonna time out on pretest 9. Yeah, we are. Oh my god. Okay. Also, what? This is so close to the memory limit. Wait, it's past it. What happened? Why was that allowed to happen? Did it time out right before it hit the memory limit? Alright. I guess we're gonna have to actually do math. Technically, we don't need coordinate compression, but I thought it was easier because... Okay, I guess it's actually not that bad. What I just need to do is, I need to add a specific number to all of these. But it's so stupid. Why would they make it 1 second? What is the intended solution here, actually? Huh, wait, maybe we could have just done the DP and, like, ignoring everything. Like, we don't even do the coordinate compression, we just do the weird DP, like, this way. I mean, I guess that's possible, but... whatever, I don't want to think about it. So I guess how this works. This is -3 below. -4. Oh. So it's negative I minus j, so it's negative m. Okay, m plus I minus j. And we can just get rid of this and I'll be happy. I feel like that's not gonna work. CR equals, let's see. Its maximum is m plus m. So it'd be that. I'm guessing it's gonna get a wrong answer. No. So this whole time it was unnecessary. Does it still do it right? It does still do it right. Okay. Let's try this then. Now this is strictly n squared and the explanation is easier. So that works. You know what? Let's just be safe and test down the other samples because there's no need to be stupid. 10, 12. Okay. Swear to God. Test 5. Man, that was painful. Okay. I'm guessing my rank isn't too good after this. Yeah. Alright. I'm scared to read E, but we gotta do it. Oh yeah, it's a string problem. Of course it is. C and N. Choose some. Okay. So it is a list of strings. Somehow I expected this to be interactive. I don't know why. And how many people saw this? 3. Oh my god. So it's gonna all come down to penalty of ABCD, and I had that terribly. So, oh, William Lynn, nice. What can we do? Wow, LGMs have not solved this yet. They've had an hour. Many LGMs. Maybe they're going for the hard version, just not getting anywhere with it. What are your official rankings? Good job, Electromaster, trying to get exactly to 2100. Anyway. Yeah, let's do this. Okay. So I guess the constraints for D weren't that bad, but I don't know why they just couldn't allow 2 seconds so you could. I mean, the coordinate compression made it nm log something, but even though it wasn't necessary, like I don't know why I didn't just do that in the first place, because that was even easier than doing coordinate compression. Guess I'll learn for the future. Yeah. Pretty sure it'll pass this in test. I mean, I hope it'll pass this in test. Okay. Anyway. Time she has to cipher. Has to spell and scroll. Adds exactly 1 letter in any place to each word it is cast on. To make the path to knowledge more tangled, some of the words. Okay. So scroll contain words in lexicographically non-decreasing order, which means there can be duplicates, which is always fun. Then has to delete some letter. Oh, okay. So that spell just adds exactly 1 letter. Okay, so it's the number of ways you can remove 1 letter from something to watch my rank fall too. More people solve B and have better penalties than I do. So the number of ways to remove 1 letter from some of the words. You want to know the number of ways. Okay. Number of ways to do this. Lexicographically non-decreasing order. What are the harder constraints? It's 10 to the 5th? Okay. And 10 to the 6th. So I'm guessing the easy version is... This is still stupid. So I'm guessing the easy version is you have... You have... Let's see. Just write out dp of I and j, which tells you the number of ways to arrange the first I things such that you remove the jth character from the ith one. And let's say j is len. I'm not even gonna say that. J is len the length of si. J is 0 index. J is len si if you didn't remove any of the characters. So then we're asking, Okay, so then the transition is O of sum of lengths with 1.5 seconds. That's probably, no. Okay, so we need some quick way to compare the strings if we remove a character from them. Let's compare the strings. Right, so what this means is, what does it mean? N is 1,000, which is small, but they had to make this 20,000, because if this were also 1,000, we could have an n squared log n solution with hashing. But that's not simple. So it's at most 10,000 squared per transition, and the transition, like, it's the complexity is O of sum of, I'm going to use the absolute, this means the length. So it's the sum of, it's way too big, the sum of the product of the lengths of the previous string and the current string for each string, because we can do those comparisons. So there are two ways to speed this up, and neither of them are easy. Okay, so there is enough memory for this, luckily. Okay, I'm not even going to try E2 right now. At least more people are solving this. More people are solving D2, so can get some suffering out of doing that. So let's say what we're asking is, why is this in samples? Okay, well, what we're asking is, yeah, there should be some like, there's probably some way to compare two strings, I guess in O1. O1 is, where's this? Search for a substring, no. Pressing a string, time to time. Not helpful, okay. Look at this again. So that's, why would they do that? All of these are not helpful. Thanks, I guess. So empty strings are going to be first. Yeah. Guess it doesn't really matter if they have duplicates. Maybe we don't need hashing. Because we're doing a lot of comparisons at once. Essentially, we're going to fix the character we move from here, and then fix the character we move from here, and see what happens. How do we do this? We need to compare two strings quickly. Alright, that's all we have to do. We say if this with a character move is lexicographically less than, let's say this with a character moved, then we can add like this dp value to this dp value. But we have to do that first. And that's no fun. Let's see how many people solve this now. Okay, so at least LGMs are getting it. Slowly, but they're getting it. It's only fair that I get a relatively bad ranking after doing so well last time. Unless I solve this, of course. Which could be possible. It just depends on my knowledge of string structures, which is non-existent. Do that at least. What if we did some like Z function stuff? What is Z function again? CP algorithms. Why did link each figures first? So the ith element is the greatest number of characters starting from the position I that coincide with the first character's mass. So let's say we have, okay, I'm going to get rid of all this because it doesn't really matter. Let's say we have the string going with a different color, A, B, C, D. Then we're gonna have some separator, it doesn't really matter. Then we have, yeah, actually we need the separator. Then let's say we have Z, A, Z, A, right? Now what we want to do is we want to compare these two. And the way we can compare it is, does that work? We want to ask, does that work? Maybe it doesn't. Let's say we get rid of this character. First we want to ask, is this the prefix of the character we move equal to this? If so, cool. No, I don't think that will work because Yeah, it won't work because the z function for this value, which is also what we're interested in, will be related to this character, but we can't have this character anymore. So we have to not do it that way. Can we do it a different way? There's some other magic string function we can use. Let's see. Maybe, no, it doesn't work. Does not work. Not KMP. Well, maybe. Just like look at this and see all the different string things there are. If it's some magic, like, if it's one of these advanced ones, I'm going to hate the setters forever, but I hope not. I mean, if the constraints weren't so tight, we can do some easier string algorithm, like hashing comparison. Is this, we're going to drop below 300? I guess we're relatively secure. Wait, why did I say secure? Yeah, secure at 250, that's what I was saying. Still not great though. It's not a T. Just not thinking about that. Oh wait, okay. So the difference between this and the hard version is that, like, you can store the DP in a vector, so it will. Maybe the hard version is FFT or something stupid where you have to just check everything. Probably not FFT. Well, maybe. No. Doesn't really matter in my case. Just gonna open this link. If each word is more than equal. Okay. No, N-A-I-S-S-N, right? Don't think this helps. KMP. Yeah, how would we use that? Can we even use the function either? No, wrong thing. Okay. So what we want to do is so get rid of this. We can build another KMP thing. So it'll be O of n KMPs, which is, I don't think it's that light on the constant because it's not, like, the KMP thing is not so beautiful for the cache. What am I looking for? Yeah, well, it's at worst O of n cache miss. I don't even know how that works. Okay. Let's see how the room goes. More people who are beating me? Yeah, there are. You got a hack on C. That's a bit scary, actually. C was that one. Don't even know what to do about this. So all my submissions are fairly fine in terms of time. Hopefully that shouldn't be a big deal. Okay, also n doesn't really matter. What does matter is the lengths of the strings here. And yeah. There's a bit more. Okay. Let's say we're comparing these strings, right? Let's say A, B, C, D, separator, then like A, B, D, can't read my own handwriting, D, let's say F, right? So then what will happen is we want to check what do we want to check? Guess we have to do better than comparing two substrings in O of 1. Maybe we can do everything at once instead of just independently. Right, so we know that for any cut, actually no, the cut is at this point. So for any cut after this point, say from here onwards, no matter what we do, this is going to be fixed because we don't care about, like, even if we remove these characters, there's still going to be a difference here. So first we can find this cut point, right? So now we have to compare things before this cut point. So we're really comparing the strings A, B, C and A, B, D. We also know that wherever we cut here, these two prefixes are going to be the same, right? So let's say we move this. Now we need to compare whatever's over here with whatever's over here. And that's the hard part, isn't it? Indeed it is. This also looks like a pain to implement in 22 minutes. I wonder what was hacked. So there was a hack on, oh, we submitted B, interesting. So there was a hack on D. Oh, someone in my room got E1, okay. Of course there's time limit issues, because they ask for n squared with 10,000, and you have to... Don't know why setters always enforce very tight string algorithms, tight constants. Just always annoying. Oh, yeah, other people are getting TLE, MLE, TLE, TLE. Wrong answer. What have other people gotten? Runtime error, that's fun. MLE. Wrong answer. Wrong answer. I'm sure these constraints were too tight. Because I made it 2 seconds for these two problems, and this one was just straight up sort, use a map. If D had a tighter time limit, it would take more operations than B and C. No idea. Got wrong answer on B. A nice progressive 789. What was I looking for? I was looking for the guy that was hacked. And they're still above me. Nice, even when they're hacked. Okay. Maybe it was a weird bug. I don't know, because he hasn't hacked anyone else, so it might have been something very specific. I guess I could have been faster on D. And A. And B, probably. That's not that big a deal. String A. Still going. What does this one do? Can we do it with a suffix tree? Many important string operations. Can it compare? If we can find the longest prefix between two strings, that's the same thing. What if we're doing this wrong? What if we want to do it the other way, where we... Alright, let's say we fix this string, and then we remove a character from this. It still doesn't really help. Alright, I have 15 minutes left. I could at least try to get the basic idea. I have no idea how to solve E2. And yeah, I don't know. maybe. Still wouldn't really change that much. Huh, if we went backwards, it's kind of like... Actually, either way, it's the same thing. So if we go backwards, it's like, so remove F first. Our prefix is this. Then we have this. Our prefix is this, and our prefix is this. So it's kind of like appending a character each time. It's like appending a character to the beginning, and then we're still trying to do comparisons. And I still think that doesn't work because it's also... Because even if we do it like this, we're comparing it with a different string each time. Like this will... If we remove this character, we'll compare this with that. Remove this character, we'll compare this with that. Remove this character, compare this with that. Didn't even cross that out. Yeah. Just gonna check things again. See how people are doing. Not great, I guess, but at least some of my other Div 1 friends are also struggling on this, so it's not exactly the easiest round. Mostly comes down to speed forces. You have to, first of all, not have a 9-minute A. That's important. And B also took a long time. C was quick. D was terrible. As part of taking a long time on A was just, maybe the recording was the issue. Reflecting on the round. Then, whatever happened with B, B was just, like, doing it wrong. That was not good. C was fine. D was just... I guess that's a better... Yeah, I guess I learned a better implementation for rotating by 45 degrees. You just add M, and then maximum is always N plus M, and then you just do whatever you want to. Create huge tabs. Any other successes on E? Been trying for a while. Maybe there was a simpler implementation of D that I missed, but I mean, rotating is still a pretty useful concept overall. You can kind of apply the same trick here. It would be this. It would be like the maximum of that, and the maximum of that, and then 1 plus this, if this is the same. Either way, it's still annoying. There's no real reason to give a problem like this. Okay, what else can I do? Suffix tree even useful here? Open that up. String search. No. I don't even know what half the things are. What is that tandem repeat? Okay. What else is going on? So we have 7 minutes left and 22 people have solved this, assuming most of them are red. There's interesting solve order. Yeah. What can you do? There's another hack on C. Assuming you started top down and then ultimately skip mine because it's right, I'm gonna hope that instead of the alternative that he just didn't get there. Yeah. Alright, well there's like nothing I can do at this point. So I might as well explain solutions to what I do have. A was a fun one, wasn't it? So essentially the idea for A is, so if it's 1, obviously it takes one thing. If it's 2, then you can construct it this way in 2 moves. If it's 3, you can construct it... No, you can construct it like so. Like so. And the general idea of the solution, which took me a very long time to find, is that essentially, let me draw a big box. Make it 5 by 5, I guess. Looks very ugly. Sorry for that dot. It's too late to fix it. Okay, anyway, with this asymmetrical box, what we can do is we can essentially see, say we fill in this with blue. Still in line. So we fill in this with blue, right? Then we can assume with this move, we're going to fill in all of, like this whole, everything we can get here is going to be filled with blue. Actually, we're going to fill this in with blue. Everything we can get here is going to be filled in with blue. So I'll just demonstrate that here. Okay, then could use the paint bucket, but that's a lot of work. So then what we get here is that we can fill in everything on this, everything on this like group of rows and columns, and everything on this group with yellow, except for this one. Then we fill in everything else, everything on here with blue, and then we finally fill it in on yellow. So essentially, we can focus only on like a specific path to the center. Like all of these paths are symmetrical. So we start here, then we go to here, then we go to here with blue, and then once we reach the center, we're done. Because like once we get to the center, everything else will have been filled. Because when we get to the center here, we'll also fill in all of the yellow ones here, and if we got to the center, then we must have filled in the other color in this box with here. So therefore, all we need to measure is how long it takes to get to the center. And let's just cut this off and use the 4x4 box. So once we do this, we can put one here, and then we're already in the center. And then we need one more because it's even, so we haven't filled this in yet. So with odd, it's, let's say this were 3x3. The path to the center would just be this. And essentially it's the same as saying the path to the center is wait, how would this work? Could we also fill it in the other way? We could do this, then that, then that. No, that would take 5. So with any odd one, we're going to start like this. It kind of depends on the parity of n divided by 2. But essentially with odd, wait, no, okay, never mind. What we're doing is we actually are starting in the corners. My bad. Yeah, I made this mistake earlier too. So then we can put this in, then we can put this blue here, and then we'll have already filled in all of blue, and then we'll do that. So it essentially comes to the length of this, which is, since n is 5, this is n plus 1 over 2. Because for all of them, it's just going to be this path to the center. And yeah, sorry, I was wrong earlier. So for odd, it's going to be n plus 1 over 2. And for even, we're going to look at this. And I got rid of that. And it's going to be the path to the center plus an extra one because it's like we won't have filled that in before once we got to the center, because this is the first time we get to the center. We'll do it with one color, and we also have to fill in the center with the other color. So this will be n over 2, n over 2 plus 1 equals n plus 2 over 2. And when n is odd, we have the other formula, n plus 1 over 2. And we can combine those two nicely with the formula floor of n plus 2 over 2. And that is the final answer. That was my submission for A, right? Yeah, it's just n plus 2 over 2. Now, okay, for B. For B. This is still running, right? Good. Didn't hit some hotkey and stop the whole recording. For B, okay, B is just an implementation problem. What we have to do is we have to make essentially a square and any kind of rectangle. So first we have to do is we have to check if there's at least one length of plank that has all four. There's at least one length of plank in which there are at least 4 of that length, because otherwise there's no way we can make a square. So first, max of all, how do I represent this? Maximum over all I of Ci is greater than or equal to 4. Alright, that's condition 1. Then we also need to make a rectangle. And essentially what we can do is we can ask, are there at least 4 different planks? No, not necessarily. We need to make 4 pairs of planks, 2 for the square, 2 for the rectangle. 4 pairs such that their lengths are equal. So let's say let's consider all Ci, right? Or sorry, I'll put it here for, I don't know, thumbnail or whatever. Let's say we have all Ci, alright? How many pairs can we get from a certain Ci? If let's say it's 3, then we can make 1 pair and then the last one is alone, right? Let's say we have 4, we can make 2 pairs. So in total we get, for each Ci, we get floor of Ci over 2. Because if it's odd, we just can't use the last one. So we want to check if the sum over all I, I'll write out the other condition here. The other condition is that the sum over all I of floor of Ci over 2, it's an I, is greater than or equal to 2 times 4, or just 8. So the second condition is that this is that. So one thing we can do to make this, actually what we can do is we can use a multiset to store all the sets of counts. Actually, I guess there's an O of n way to do this. Okay, I'll just go over my solution. So we'll use a multiset to store all of the counts of each plank in reverse order. Then what we notice is that once Ci is less than or equal to 1, we can stop. Because no matter what, every Ci less than or equal to this one is going to contribute 0 pairs. And because we're only checking if it's greater than or equal to 8, we're only going to look at most, actually 3. We're only going to look at most 3 different values of Ci. Or I guess at most 4. One of them has to be greater than 4. We can first check if the biggest one is greater than 4 by looking at the greatest element in the multiset. And then after that, we iterate over all Ci that's greater than or equal to 2. And once either our count is greater than or equal to 8, or we hit one that's less than or equal to 1, we can stop, and then we can check if both conditions are satisfied for each query. So this is, it's just basically O of n log n log something. Actually, the array elements are at most n, so it is n log n. Actually, n log n plus q log n. So we can do something fancy like n plus q log n. And yeah, that is B. Annoying. Very annoying. Most of these problems are annoying. Okay, C I have already explained. I will leave the timestamp for in the description. Basically, as I was solving it, I went over the whole solution. D, okay. I've kind of explained most of this one already, but I'll still do it, I guess. So let's create some sample, right? Let's say A. Let's say A, B, C, B, 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 D. Okay, we'll just use that. So the first trick we're going to do is to rotate it 45 degrees, right? Okay, so what this does is this makes it like this. So we have, oh, I'm going to make this bigger. Makes it like this. So we have A, B, 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 B. Wait, no, that's wrong somehow. This should be, sorry, D, B, C, and then B and B. So now instead of counting rhombi like this, we can instead count squares in this, where all of these have to be B. If this one was, let's say, F or something, we still wouldn't be able to use it. Also, this last one is B. So how do we count such squares? Well, we can kind of do it with a dynamic programming approach. Let's say dpij, I'm just going to write out this and not the whole thing. dpi and j is the maximum number of squares where the position ij is the bottom right of the square. So for example, this wouldn't have any squares except itself. And this position would have two squares, this big one and itself. So this dpij would be 2 because it's the biggest square where it's the bottom right is 2. So there are three things we can check here. So it's min of dpij is min of the count of, I'll get into what all these mean, but it's the minimum of count up, count left, and 1 plus dpi minus 2. Okay, also what we're going to do is we're going to put some filler in here, like I did with equal signs, so we can simply have this as an array. That's the whole point. So we can make this an array, and that squares will be actually square instead of rhombi. dpi minus 2, j minus 2. Okay, so first C up. C up is essentially like, it's kind of like a zigzag thing, where we have to count the longest. It's like the longest that we can go up without running into a letter that's different if we zigzag like this. So this C up will be 1 because we can get here, and because we're skipping by 2 because we want to count these squares, and these squares have to skip by 2. However, if this letter were something else like F, it's a different color. If this letter was something else like F, then this C up would be 0 because we can't zigzag like this. So the code for this is not fun. We have to do a lot of stuff, but yeah, and C left is basically the same thing. How far can we zigzag this way without hitting a different letter? Then essentially this is going to be these are going to be the sides of the square. So we're going to take the minimum of these because it has to be a square, so we want the one that's less. Like obviously this square, like this, let's say this goes farther than this, and this only goes up to here. Alright, we're going to make this square, and then we can only extend it out to here, so it's going to be the minimum. And the other thing is 1 plus dpi minus 2 j minus 2. So because we have to extend a square here, and let's say we're building this square, right? So this essentially covers everything, right? So what we're doing is this zigzag is checking this part of the square. This zigzag is checking this part of the square, and dpi minus 2 j minus 2 is checking the rest. Like let's say we had this, right? So the biggest square we would have is here. Wait, that's a bit of a weird diagram, but actually this zigzag, it's more like this. Yeah, more like this, where this zigzag is checking, sorry, different color. This zigzag is checking this part, this zigzag is checking this part, and dpi minus 2j minus 2 is checking the rest. And of course it's the minimum of all these, because if any of these is blocked, then we can't make this square. And also we can only, one final edge case, we can only count this if this is the same as this. Because at the same time, like this, actually that's not even necessary, because if this were different, the zigzags would catch it immediately. But still, yeah, we can only check this part if this is the same as this, as well as this. Because if this were different, then we wouldn't have a square at all. So, yeah. And then if this minimum evaluates to 0, then we have a square here with itself, so we'll set dpij to 1. And then we'll continue on. And then once we have this dp, then the answer is the sum over all dpij except for the filler characters. Because what we're doing is we're, like, let's say we have this square and then this square, right? Both of these are squares. So even though the maximum square is 2, we still have a square of side 1 that ends here. So we have to also count this one. And if we had some bigger square of side 3, then we would also have a square of side 2 and a square of side 1. So we would count all of these. So it would just be overall the sum of all dpij. And so I'll write that out. Ants is the sum of dp, I, and j. And then we print that, and we're home free. So that is this. Rip second thread. I guess using Java screwed him over because the constraints were so tight. Okay. Yeah, so I don't know. In terms of speed, it was not great, but at least I solved A to D. I have no idea how to solve E1 or E2, so I can't really explain those right now. Maybe I will later, but for now I'll just upload this. And let's see. Up next will be, I'll do round 663. Hopefully it'll be better. I will screencast this round, but I'm not going to commentate on it because it's rated for me. So I will just, actually I'll just, yeah, I probably will screencast it. Yeah, that's what's up next. Anyway, that's enough of this. Okay. Bye, everyone. Hope you enjoyed watching my struggles on everything but C.